Good afternoon, everyone. Welcome to another live session at the Reactor. My name is Rav, and I am the program manager at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful and mindful of other people's views, understanding of differences, and be kind and considerate in the way you engage. Today is the first episode of how to use Azure to kickstart your DevOps lifecycle. And in today's episode, we'll talk all about build, test, and deploy. The session will be led by Liam, who is our regional cloud advocate at Microsoft. The chat will be open throughout, and we do encourage you all to participate. And with that, I am going to hand over to Liam.
All right. Hello, everybody. So great to have you here. It's fantastic. I'm just going to share my screen and get some slides up. Okay, so hopefully you can see my screen. Hello, this is the first session of my DevOps series. This is episode number 1. My name is Liam Hampton. I'm the cloud advocate here at Microsoft in the UK, and I work alongside the Reactor team here in London. So, a little agenda. I like to do this because it gives you a feel of what we're going to be talking about, what I'm going to be doing and showing you throughout the session. So a little bit about me, who I am, where I'm from, and what I do. Some information about the series, some DevOps fundamentals, because this is the very first episode. Common mistakes that I see made. As a cloud advocate, I speak to so many teams and so many people. I see so many mistakes being made, and it's almost more often than not the same ones. And then we're going to look at a little project, and we're going to kickstart the little project that I'm going to be creating, and I'll take you through. And it's just going to run throughout the series, each episode throughout February. So, about me, who am I? I'm a cloud advocate, as I said. I'm an open source contributor. Some of you may have seen that picture before. It is my LinkedIn title, and it's from Think. So prior to this, I was a full-time software engineer at IBM, and I coded in Golang and Node.js. And that was actually for Call for Code when we made it to the global finals and were able to sort of present our project at Think, which is IBM's big UK conference. I'm also an author, technical blogger, so I'm actually part of the Apollo program, which is fantastic. And that is because I do blog about IoT. I'm an enthusiast. I do lots in TinyGo, which is kind of like a subset or a smaller binary, or sorry, a smaller compiler for Golang for IoT devices, microcontrollers, and WASM. So yeah, that's fantastic. And I'm also a public speaker. I love doing events like this and teaching what I know. So about the series, what are we doing? So there's 2 goals that I really want people to take away from this. This is the beginner series to DevOps, so like a real introduction. And we're going to be talking about or the understanding the fundamentals of the DevOps lifecycle and the processes involved in that. And I really want people to take that away, and hopefully you learn something from this. And secondly, it's even better if you can put what you've learned, those learned lessons, into practice, whether it's in your team, whether it is your individual project, so on and so forth. Those are the 2 goals that I want people to take away and achieve from this series throughout February. So, episode number 1, what are we doing? The fundamentals. Really, what is DevOps? Where did it come from? And where's it going? What do we do with it at the moment? And obviously some pitfalls. We're also going to create an application and deploy it to Azure into App Services, but more on that later. The second episode, which is next Tuesday, will be an introduction to CI/CD. So continuous integration, continuous delivery. Some people may say continuous deployment, but we can talk about that one later. So we're going to automate some of the manual steps that I'm doing today. Then episode 3, in 2 weeks' time, is going to be an introduction to infrastructure as code and what we do when sort of deploying our services with code. So we're going to kind of foresee what we've done prior to this, and we're going to automate everything with a file. Now, I haven't written that episode yet, and that's deliberate because I would love to get your input. So please feel free to throw it in the chat, whether you want to see Bicep, Terraform, whether you want ARM templates. Please give me some suggestions, and I can help teach you and show you how to do that in Azure. Finally, at the end of that, I'm going to release a cloud skills challenge for you all to complete. So each individual episode is going to be a subset of technologies that we're going to use, and going to have a skills challenge associated with that from MS Learn, which is going to be brilliant because then you can put into practice what you've learned. You can gain XP, and you can, you can go forward with it and put it on your CV, because that is really important. So enough about that. Let's talk about DevOps. This is why we're here. Let's talk about it. If you Google DevOps, you are going to see this. You're going to see so many verbose explanations of what DevOps actually is. Kind of leaves you feeling a little bit like this. You're kind of a bit overwhelmed. You don't really know what it is, where to start, who's correct, because everybody has their own sort of take on it and their own nuances. So, broken it down a little bit. DevOps is development and operations. Dev and ops, that's what it stands for. It's cultural philosophies, tools, high velocity, and collaborative. So you can kind of get a gist of what it is. If you look at it at a high level, DevOps is a process, it is a culture shift, and an encapsulation of technologies. Now, that is not to say that it's not these three. There are other bits to it, but on a high level, this is technically what it is. The unofficial logo of DevOps is an infinity loop, and there's 8 stages to it: plan, code, build, test, release, deploy, operate, and monitor. That is brilliant, but what does it really mean? Let's break it down a little bit further. When you plan, you are future-proofing. You're future-proofing your product or your team's development for what's going to happen later down the line. You're planning for that. You're going to reduce technical debt. So a really good example of this, I worked in a team not too long ago, and we wrote this brilliant project in Python. We got to version 0.04, so it wasn't like a full release, but it was still a couple of months worth of work. We scrapped it. We turned around, backtracked, and went and wrote it all again in Golang. Now, we didn't really plan ahead. We had built in a lot of technical debt there because we had to start again. So that's kind of not wasted time, a learned lesson for sure, but we could have just done a bit more research at the beginning and gone forward with it in Golang from step or day number 1. You plan for security as well. Security is a big topic, and I'm probably going to hammer that home with this presentation a little bit because it is massively overlooked. Really is overlooked by developers and teams because third-party imports, software that you're going to bring in, ad hoc plugins, etc. You're kind of relying on other people at that point. Then we have scalability. You want to plan to scale. So it's all good sort of planning building your application for 100 users or 100 concurrent users a week. But what happens when you get to Friday? You release a sale on your online shop and you have thousands influx. It's going to crash. You need to think about scalability. You need to see or think about where you're going to be going with it. Next, you have code. What are your core requirements? How can you maintain that? Is your code really easy to maintain? The bus number. What happens if I don't have to work tomorrow and I suddenly leave? Who's going to pick up what I'm doing? So you've got to understand what everybody's doing at any given point. And finally, version control. Well, I mean, I could do a whole series on version control, but there's 2 main ones. You have Subversion and you have Git. One is centralized, one is more decentralized, and it's just about where the code is and how you're really working together as a team. The more common one, or the most common one, is Git now. Build. What happens in the build stage? You're packaging your code for release. You are taking everything that your development has done, your team and developers, packaging it up, and you're going to get it ready to ship. That's kind of almost a pin in DevOps lifecycle. Because this is where it really starts to get automated. This is usually the start of a CI/CD pipeline. CI/CD, continuous integration, continuous delivery. And then finally, you have test. Now, you can argue TDD, which is test-driven development, could be part of the coding stage. Because you're building code, you should follow TDD. I'm guilty of this. I haven't always, but it is certainly a really good practice to have. And I use RAG, and RAG is red, amber, green. Write the test first. What fail? Red. It fails. Then you write all the code you can to get it to pass. It could be the worst code you've ever written. As long as your test passes, that's fine. Then the green step is you refactor your code and you get that code ready release. It's the best code you've written at that point. So TDD is arguably part of code, but it very much is part of test. That improves your readability. It improves reliability. And by doing that, you're kind of making unit tests or integration tests and just making it flow a lot better within the team. The ops process. What happens in the ops process? So like I said, the pin was really at build, where it's usually automated. But in the ops process, this is now where we're moving to operations. Release. How are you going to get that code into production? Are you going to recreate what's already out there? Are you just going to recreate version or replace the old version with the new version? You might get some downtime. Is that okay? Only you can tell me, because that is your development. Are you going to do a rolling update? Are you going to do blue-green deployment? That is arguably the more favorable one at the moment. Maybe Canary or A/B testing. Now, those two are very, very similar. Canary and A/B testing is kind of when you release your new version to a subset of users. A/B testing comes with a little bit more restraints. So let's take an example, maybe Instagram. Okay, you might roll out a new feature, Instagram, and you can only have this feature available to people with over 1 million followers. That would arguably be A/B testing because there's a constraint. Whereas Canary would say, open this up to a subset of users on Instagram, and then it doesn't matter whether you've got 1 follower or 1 million followers. That's kind of a really good example between those two. And Shadow, this is personally my favorite because it allows sort of fluid development in my eyes. You can put both your new version and your old version into production. Your old version will reply to your requests coming in from your users, and the new version will just consume the request, but feed back the response to the development team, not to the users. Then we have deploy. So you're really looking at the environment that you're pushing to. So is it going to be a container? Are you going to push to a virtual machine? Are you on-premise? Are you in the cloud? Are you in a hybrid cloud scenario? This is really where you're looking at where is your code going to live in the long run in production. That's what the deploy stage is. Following that up with operate, that is, was it successful? Did your code deploy successfully? Is it working the way you want to? Are you testing live loads? Is it behaving? What kind of feedback are you getting from your application at this point? And this is a perfect time for some chaos engineering. You can throw out some new small feature without testing it properly, see how it handles in the wild. That's kind of the idea behind that one. And then finally, we have monitor. And this is this is the end of the life cycle. And this is where you're going to look at your performance. Is it performing well? Have you got any bottlenecks? Or are you getting good customer feedback? And if not, get ready to put that into your next sprint. Look for errors. Are there any edge cases? Every software developer will tell you he or she has tested their software or their bit of code perfectly. Covers every case. That's not true. There's always a customer out there who will find that edge case and who will break the system. So perfect time to take that back and regroup. Start your cycle again. And finally, look at if there's any knock-on effects. Has anything happened to the rest of the deployment? Maybe you've got different microservices up that are maybe not talking to each other properly if something has gone wrong with an edge case. You know, these wild cards, should we say, these error cases. I'm not going to bore you with common mistakes, but here are some of them. Oversimplification. People and teams see this as a really quick fix. It's like a bell curve. It always gets worse before it gets better, but teams don't stick with it. So as soon as it starts getting worse, it kind of drops and they go back and they slip back. Oh, it's getting too bad. We're not going to move on from this. Oversimplification means that they are just not willing to stick with it. They're going to simplify. They maybe take out some of the steps because maybe they don't feel testing is as important as it should be. Maybe they can just combine two of them. Maybe they're not going to monitor it properly. Maybe they don't mind about it. So oversimplification is a really, really big problem here. Secondly is underutilization of automation. Now, what I mean by that is it's full of tools, automation tools. That's essentially what DevOps is doing. It's automating all the manual steps, make it easier for developers. Underutilizing those tools are out there. It's detrimental to your project because you're really not going to gain anything from that. You're just going to make it harder for your team and development. So next we have using the multi-hat approach, or not using it rather. And that's just a term that I coin when developers should be using or should be able to do multiple things. They should be able to write the code. They should be able to test the code and maybe learn how to release it on deployment. Secondly, you should be able to, or fourth rather, you should be able to test other people's code. You know, so using that multi-hat approach, some teams think I'm going to be a developer, you can be a tester, and you can be a release engineer. And that's segregating three very key points of the DevOps lifecycle in your team to, or delegating to different people. Each one of those should be able to do all three. Next, we've got scope creep. I am super guilty of this one. I do this too much, and I still do. But it's something I'm getting better at, and it's a learned skill, because you may think that if you're writing, or if you're coding for a ticket or an issue, you may want to scope out. You may want, I'm going to make my life a little bit easier tomorrow for the next ticket because I can do it now. Just stick in your lane, stay in your lane. I find that hard as well. And again, I've put security with a question mark, because security who? Teams don't plan for security. They overlook it. Log4Shell or Log4j, whichever way you want to say it. That is a really, really, really good example here, because teams thought it's a third-party software. It's got longevity. It's well trusted. Everybody uses it. Well known in the industry. We can use it until one thing goes wrong and it brings everything down. And the amount of friends and developers which I saw coding and working on Saturday and Sunday to fix it for their production system, wouldn't want to do that one again. So you have to plan for security. You have to look at it quite seriously. And again, talking to lots of developers, they think, oh, it's fine. I'm just going to import all these sort of third-party packages without really thinking twice about them. There's tools out there to help you with this. Snyk, for example. Snyk is a really cool tool. It will help you scan for vulnerabilities in open source packages. So it will help you and save you putting it into production. You've got many more as well. And then finally, it's a loop. People forget and don't really realize it's a loop. So you go round. Once you've done it once, you do it again. You have a retrospective, what went well, what you could do better, what you're going to do next, taking customer feedback, how can you plan that in? It's all about sprints and getting better and iterating over a loop. So finally, who really benefits from this? Who benefits from all of this development and all of this quick, continuous integration and delivery throughout this process? Everybody, developers, the quality of the product gets better. Sales, they're able to sell more. Customers get a better turnaround on their development product that they're wanting. Test engineers, they can also do development. Developers can do testing, so on and so forth. Everybody benefits from DevOps Lifecycle if it's done correctly. If each stage is adhered to and sort of taken attention to, it is, everybody benefits. It's brilliant. So that segues nicely into tooling. What tools do you use at each step? So I've kind of covered a whistle-stop tour over each of them, but what tools do you use at each stage? Well, planning, you may use GitHub or Jira or maybe Asana, any of these tools, team collaborative tools. I know you may even want to use Slack. That's a really good one as well. Moving on, in code, you can code in any language you like. I've chosen Go because I'm a Go engineer. Git or Subversion for version control in this instance. When you're building, you may use Maven or Gradle or Go Build and so on and so forth. You may even have make files that do all this for you. There's so many options at this point, and it just gets bigger and bigger and better. When you're testing, you may have Cypress for front-end testing. I know if you're using React, I've certainly used it. Maybe Mocha or Chai if you're using Node.js for unit testing. If you want to release, you've got pipelines available. You've got Jenkins, Travis CI, you've got GitHub Actions. There's so many tools out there to help you do this. And then when it comes to deployment, where are you deploying to? What environment are you deploying to? Virtual machines? Azure Compute Power? Are you going to be using containers? Docker, for example? All up to you. But there's so many options available. And when it comes to operating, Kubernetes, container orchestration tool, Ansible, parts of infrastructure as code. There's so many available. Again, monitoring. Finally, you have things like Splunk, Logstash. You've got analytics in each cloud provider. You can see how this can get really overwhelming really, really quickly. So what do cloud providers do? Well, at Microsoft in Azure, we offer the Azure DevOps Services, which encapsulates everything for you. Boards for planning, pipelines for deployment, repos to store your code, test plans to help you test your test suite, artifacts to store your images, to build your CI/CD pipeline to store your images, and extensions. So there's so much to do in such a great service. It's all available for you. But all the cloud providers do this because it's so overwhelming. And if you would, there is the link on the screen there. You can visit that if you want for more information. But another really good segue is the project that we're going to do here, because I'm not using this. I'm going the wild, wild west route. I'm doing it the other way. Well, I'm going to cherry pick some tools and I'm going to build with them. So the project, what is the project that I'm going to build with you? It's going to be a portfolio of my travel. I love to travel, at least prior to the pandemic I did. It was fantastic. I went to lots of places. So I want a portfolio. I want it to be scalable, adaptable, so really quickly and easy to change. I want it to be automated. And finally, I do want it to be fun. There's nothing worse than just putting up a simple server and having it say, hello world. Nope, it's hello Liam's world. To do that, I am going to, or in fact, to save time, I'm actually written this in Go. And I've used Git and GitHub and handlebars templating. So handlebars templating is a sort of a server-side, well, a front-end framework to get server-side variables into your front end. So you can sort of grab, like I'll show you in this instance, some variables from the server, and I will plug it into the front end to sort of have it displayed. And Rav, if you could plug that one into the chat, there should be a link for that if you want some more information on it. Second, I'm going to containerize the project. So it's all good that it runs locally, but I want to containerize it. So I'm going to use Docker, and it's going to package up my code, and it's going to be ready to put wherever I want it, wherever I want to put it, whether it's in the cloud or your machine or wherever. Then we're going to deploy it into Azure. Now I'm going to take this, oh, the lights have just gone off. I'm going to take this one, and I'm going to put this container into the container registry. And the container registry is basically a store for all the artifacts that we're going to build. So imagine you've got multiple containers. You can stick it up there in Azure. And it's just a private repo, just like Docker Hub. From there, we're going to grab the container and we're going to deploy it into App Services. There's a reason I've done it this way, and I will show you when we get to it in a minute. But yes, that is the presentation for now, and I'm going to jump into a project. So if I come out of my presentation here, do we have any questions in the chat already? I think now's a good time to break quickly and see if there's anything there. Okay. So just having a quick read. Hello, everybody. ARM and bicep, please. Okay, bear that one in mind. Terraform, ARM templates, lots going on down here. Love it. I love the interaction, everybody. Security by design, exactly, Alan. What else we got? Go mention of Azure DevOps. Yes, so Azure DevOps was there at the end. Brilliant service indeed. But we're going to do it the other way. We're going to grab some code, and I'm going to show you how to do that. So if there's no more questions at the moment. Right, so hopefully that's not too small, but I will zoom in nonetheless if I just make that one big. Okay, so this is a repository that I've got my code in. I am going to clone this. So if I open up my terminal, so if I just go in here, so I'm just in my temp folder. You can put this wherever you like. Like I said, it's in GitHub. You can all grab it. I'll put the link at the end. So if I do a git clone and just pop it in here. Cool. So now that is in there. Let's go into that directory. There we go. And I'm going to open that up in VS Code. Fabulous. That looks rather big, but that's fine. Let's do a little bit of a code walkthrough. So to start with, let's look in my views folder. In my views folder, I have got a main handlebars template. And this is HTML for everybody that doesn't know. That is some of that's all the web pages are kind of built on, and styling. I've just got some inline styling because there really isn't much to do or much templating in this file. We've got the body, which has got a header and a footer in it. Of course, you can put this elsewhere, but for the way I want to build this, it's good in the body. And we've got embedded. What does embedded mean? Embedded means that I can grab my index.hps, which is a handlebars file again, which has just got a div tag and it's just got some more HTML. That's what it is. Now, the eagle eye may have noticed we've got a title and India description. Now that comes down in a second, but that is part of handlebars templating. I'm able to take server-side rendered variables and plot them into the front end and display them and render them. Again, in my partials, I've got a footer and a header, which is just kind of like a nav bar, and a footer that says, my name, and you'll see it in a moment. What else do we have in here? So that's the views. So that's just all you're going to see the front end. So that's HTML rendered with some handlebars templating. If we look down here, we've got a license, a go mod, go sum, and that's because I have got my packages in here. I've got a test file. You may be wondering, why do you have a test file? Well, I have a test file because I want to show you that we can test these things. I'm testing for the files existing. So I just want to make sure that my test will return true for main.go being in the current directory, the go.sum and the go.mod file being in existence. And as we can see there, we can tell with our eye, but this would be good for automated testing in episode number 2. And if we don't get what we want, so I'm just going to loop over that. This is called a table test, where you just put an input and you say, I want this input, and I expect a certain output. In this instance, I'm calling OS_stat, which is just checking for the files being available on my system. And if we hover over that one, if it doesn't return true, it will return an error. So the error case is if the error is not nil, so if there is an error, then throw out a string that says, hey, I expected this, but I got this. And then I'm just putting in the values retrospectively with that percentage sign and S with the variables at the end. So if I run that test, if I open up a terminal in here, I can do go test and hopefully should run true because I have them. Okay, cool. So it passed, which is brilliant. So that is my test done. Now let's look at my main file. Let's close this terminal again because it's pretty big. Going from top to bottom, we have got some imports. I have got a function called render index. And what that's going to do is it's going to run my handlebars template and pass through the values that I want it to display. So this is the server we're looking at now. We have got some routes, and I've just got one route. I've just got the home route, which is just a slash. And all I'm going to do is render my index. So when I hit that home slash, I am going to render index. So I'm going to call that function, pass those variables through to layout main, and that's going to display on a page. And then finally, like with every program, we have the main function. And the main function is just going to render or bring in the handlebars templates from the views file. And it's just going to say, hey, assign engine with handlebars.new. So just letting it know that it's there and that it is readily available. Then we're going to create the app. And the app is going to be a Fiber server. And what that's going to do is going to take in the views, which is the engine, which we've just assigned as a handlebars template. And hopefully it's kind of making sense that it flows through nicely. In the configuration for Fiber, we're going to say, when you display this route, display that page. That's what it's doing. So when we call our routes app, we're going to get a nicely templated HTML sort of screen. It's going to list on port 3000. So let's run this manually. So in the terminal, I am just going to do go run main.go. Now, the idea is not to teach you Go in this episode, but if you would like some more episodes on Go, please, again, throw that in the chat. I would be happy to create some Go content for you all. So if I was to run this manually, hopefully it will spin up a Fiber server, which is, by the way, very, very similar to Go Node Express, as some of you may have picked out with the app.get. Very, very similar, which is why you can use handlebars so easily with it. So if I go to that one, I get a really rubbish loading screen. And that is because the image that I'm using is from Imager, which is my image, but it doesn't like 127. If I put in localhost and colon is there, wonderful. So this is the real beginnings of my application. I've got a title, which I'm passing through from the server. I have got a description, let's visit India. And I've got some headings, which don't really do anything at the moment, but I've kind of tagged them already. But that's going to come in episode number 2. So please stick around for that one. This is really cool because I've got a running app locally. What if I want to get this in the cloud? How do I do that? Well, we can close this down and we can open up the VS Code. And what we can do is close that terminal for a second. We want to Dockerize it. So like I said, I've got the code. I want to containerize it. I'm going to use Docker. But in here, I'm going to write a Docker file. And a Docker file is just like a load of layers. It's a package of the code. So I'm going to grab an image. And the image I'm going to use is Go. And it's a Golang image because obviously I want the base is written in Go. And inside the image of Golang, it already has everything installed for me. I don't have to do anything extra there. So let's grab a Golang image. I'm going to use the same. Go version as I've got locally, which is 1.17.6. And that just keeps it consistent with what I have locally as to what I want it to run in the image. And next I'm going to say Alpine, and I want Alpine, and I want Alpine 3.15. Alpine image is just usually the skimmed down version of what you would usually get. Wonderful. So I've got an image. Let's create a working directory. Now the working directory I want in this container, I want that to be home. I just you can call it app, you can have it in your root directory, have it wherever you like. I just want it to be in home. Then I want to copy, and I want to copy my go.mod file, and I want to stick that in my root directory of home. So, my current dir. Next, I want to copy my go.sum file, very much the same, stick it in the same place. Then I want to run a command. Now, you imagine this is just running through a terminal. So the command you put in here is very much what you'd write into a terminal. So I'm going to do go mod, and I'm going to download. So I want to install all of my dependencies. So if I look in my mod file, I can see I've required Fiber version 2, and I've got templates. I want to bring these in, install them into my project. So go mod download. After I've done a go download, I want to take the views file. As you can see, I've got a views folder over here. So if I can do a mkdir and views, just like so. Next, I'm going to copy everything that has the Go extension at the end of the file, just to make sure I get my main.go, my test.go, etc. And if I wanted to have any more, if I build this out with more roots, I could abstract it even further. And I could have different files with the extension.go and copy that all across. Just kind of make sure I get everything all together. Then we want to copy everything from views and put it into a new folder in the container called views, which is awesome. So now we have all of our code, or all of our code files, should I say, into the container. After we've done that, I am going to build a binary. In Go, when you compile the code that you've written, you build a binary with it. And that just means that you can distribute it. You can build a binary for Windows, for Mac OS, for Solaris if you really want. Loads of different distributions. There is a way to, that's a whole different kettle of fish, but I can go into that quite deeply another time. Essentially, I can build a bunch of binaries. For this, I want to build for Linux, because that is the base image. I want to build this for Linux. So if I do Go operating system, and I want to use that one, and I want to tag that as Linux. Next, I want to do the architecture. So I want to do Go Arch. And for that, I want it to be AMD 64. Okay, so I'm building for the AMD 64 chipset. Now, this is where I'm going to come to something in a minute when I build this locally, because I'm actually running on a Mac M1 chip, which is ARM, not AMD. But this caught me out when I was building this. Then I want to do my command to build the binary. So I'm going to do go build, and I'm going to remove all the debug flags as well, because this is going to be a production grade build. So I'm going to do LD flags, and that's going to remove the symbols and flags internally when I build the binary. It helps bulk it out, slim it down, because it's quite bulky if you don't do it, if you have a big binary. For me, it's just good practice. I like to do that. Then I'm going to give it an output, and I'm going to call it website. Because if I did give it an output name, it would probably call it whatever my directory is called. It would be DevOps Series 1. Wonderful. So let's recap quickly. Got an image of Golang, base image. We've got a working directory of home. We've copied across some files, the mod files. We've downloaded the dependencies. We've made a new directory, and we've copied all of the Go files over and the views directory. So I'll be able to run the server and render the front end through the templating. And we built a binary, and this binary should run it when you call it. After you have built that, we are going to run chmod. And chmod, because we want to give it all of the access that we can when it comes to running it. Some systems get a bit flaky with this. It's just the access rights, whether it's read, write, execute, etc. It's more like an operating system thing. So that is wonderful. I could just do expose 3000 here, which is the port, and then run endpoint or entry point. And I can give it an executable, and this executable is website. However, if I build this file as it is, this is going to be about 1 gigabyte in size. That is massive, too big to deploy into the cloud. So what I'm going to do is I'm going to make a multi-layered Docker image. Now, using a multi-layered Docker image means I can do all the build at the top, and then in the second image, I can just copy all the things I need from my build artifacts. So in this instance, it's going to be my home views folder, and it's going to be my binary that I've built. So to do that, I'm going to say above the expose, let's just do this one. Let's do from again. And from here, we are going to do, I don't want it to be from platform. I want it to be from Alpine, and I want to keep consistent with what I've got above, so 3.15. And what it's going to do is going to take the Alpine image of 3.15 and it's going to use that instead. That's the base image now. Now what I can do is I can copy from a stage. Now a stage, I'm going to say from build. Now I'll come back to this in a second, but I'm going to copy from the build stage, which is the stage above, and I'm going to say the home, and I'm going to say views, and I'm going to stick it in a new folder called views. Okay, and the same again, if I do copy, let's say from stage, and we're going to do build, and we're going to take it from, we're going to take the binary this time. So we're going to do home/website, which is what we built. It's the output over here. And then again, I'm going to put that in the home directory. It doesn't need to be in a new folder like views did, but I'm going to stick it in the home directory. Now from there, I can say expose 3000. Then I can give it the entry point of the binary when we call it in the container. But there's one other thing that I haven't done yet, which I need to do. And I have specified, I'm copying these files from build, but I haven't done anything about this stage being the build. So I can say, just like so, pop it up there and say, as build. So it knows when it comes to building this image, it is a build. That's the build stage. Copy these artifacts from build, put into the new one, which is the Alpine image 3.15, and then run it from there. That will slim down the binary a long way. Hopefully we should aim to get a binary or a Docker image, should we say, of about 15 megabytes. So if I was to do the Docker build command, so I should make sure, so my Docker running, my daemon, I'm going to do a Docker build. So Docker build, and let's do platform. Now this is, if you remember, this is the issue I had. So when I was building this, I'm running on a Mac M1. Now I have naivety, yes, that word, never had to specify platform before. I've always just gone off the Intel chip that I've been running until now. So I'm building for AMD 64, which is the cloud architecture machine, the server that's going to be running on. And when I did this locally, I was building on ARM chip, which means they're everything. So always specify the build, the platform that you're doing. So if I do platform, and I'm going to specify Linux, and I'm going to do AMD 64. Nope, yep, 64, like so. And then I'm going to give it a tag, and I'm going to say DevOps on Azure, episode 1, version 1. So this is going to build for platform Linux AMD 64 and tag it DOA EP1 DevOps on Azure episode 1. And I didn't specify the Docker image. Of course, I always forget that. It's the period at the end. So specifying the image, if I put a period, it will build this image. Lovely. What have we got here? Internal load metadata for Docker IO Alpine 15 latest. What have we done wrong? That's not good. Of course, I didn't put my semicolon there. Of course, completely overlooked that. So let's just make sure that didn't build anything. If I do Docker images, cool, nothing was there. Let's clear that one. Let's try that one again. Awesome. So we have got a 14.6 megabyte image, or Docker image, shall I say. Fantastic, it's built it. So what do I want to do with that one? I want to tag it. So if I do Docker tag, actually don't want to tag, I don't want to tag it just yet. I actually want to create a container registry in Azure. So, or a resource group even. When we deploy to cloud, we have a subscription. Inside the subscription, we're going to have resource groups. And inside the resource groups, you're obviously going to have resources. So we want to create an app service in the cloud. So to do that, I need to log into Azure. So let's just log into Azure command line. So if I do AZ login, that's going to take me to a web browser. I'm going to select my account. Wonderful, we have logged in. So let's go back to VS Code. Wonderful, we've logged in here. So let's clear that one. Next, I want to create a resource group. To do that, I'm going to do AZ group create, and I'm going to give it a location of UK South, because that is where I am. I'm based in London. I'm then going to give it a name, and I'm going to call this Liam DevOps series. Okay, and actually we can just hyphen that one in here to make that a little bit more readable. So I'm going to create a resource group for me in the cloud in my account. So let that run. Awesome. We have got a resource group. What do we do in a resource group? We build a resource, or we create a resource. So in this instance, I want to create a container registry to store my image. So I'm going to do AZ-ACR, so Azure Container Registry. I'm going to create the resource, and I need to specify the resource group. So resource-group. Once I've specified the resource group is Liam's DevOps series, so I can copy that one from there, paste it in. I then want to give a name to my container registry. So -n for name, and I'm going to call it, let's say, DevOps on Azure. Wonderful. So that is going to create a resource group. It's going to create a container registry called DevOps on Azure for me. Now, I actually want to give that a SKU. So that is going to tell it what kind of plan I want. And I'm going to say I want a basic plan. Ooh, I don't want all caps. I want it to be basic. I don't need standard. I don't need anything extra. This is a real basic application, so I'm going to call it basic. Finally, I actually want to have the admin enabled, so I can log in to this container registry. I am the admin. I want to be able to push, create, and pull from it. So I'm going to say that is true. And hopefully, with a bit of luck, that will run. Wonderful. So it is kicking off. It's running. And what this is doing, it's gone and created it. Wonderful. So to be honest, I can go and check this in the portal, but I kind of believe it's all there. And if it isn't, if something's gone wrong, it will just tell me anyway. So lastly, I want to log in to that container registry. And that is really quite easy to do. I am just going to do login, AZ, sorry. What do we want? This one. So AZ, ACR, login. And I want to give it the name, which I've just called it. And I can find it a little bit up here, whatever I just called it. There we go. So the login server, DevOps on Azure, ACR, Azure CR.io. So that may seem familiar because obviously if you use Docker Hub, you'll have a Docker registry, very, very similar. And I don't need those hyphens in there. I need it to be like that. Yep. So hopefully that will call. That uses a Docker engine underneath, and like the background, it kind of, I don't know what that thing there, that endpoint suffix, it's automatically limited. Wonderful, that's fine. That just means got rid of it. I didn't need to paste that in. I just need to paste the name of it. But it used the Docker engine, the daemon in my local host to sort of log into this registry using my credentials from my Azure account. Cool. So if I do Docker images, I've got this one here that we built a moment ago, 14 megabytes. I now need to tag that image so I can push it to my new registry that I've just created. So to do that, I'm going to use Docker tag. Oh, if I can type correctly, I'm going to use the DevOps on Azure, episode 1, version 1. And I want to call this one here. So I want to make sure that I'm pushing to that registry, which I've just created, and I'm going to call it DevOps on Azure, episode 1, version 1. And what it's going to do is going to tag the image locally. Wonderful. We have got 2 images. One is a tag of the other, and it will push to DevOps on Azure, my container registry, in the cloud. That's what we're going to do. So lastly, if I do a Docker push, hopefully this will go up to my container reg. And all I have to do is push this image, so I can copy and paste it from my command line, and I specify version 1 because I want this tag to go up, this version, this image, I want it to be pushed. And as you can see, it's super, super quick. It is lightning quick because it's such a small image. It's done, just like that. If that was a gigabyte, if I built this without it being a multi-layered image, that would take ages. And I was doing this yesterday, and it was timing out, completely timed out, because it just took so long. So if I go into my Azure account, so let's just reload this, make sure I'm in. Oh, of course, I've logged out, but that's fine. We will log straight back in. What we've got here, if I look in my resource group, I've got Liam DevOps series, and I've got DevOps on Azure. So I've got a container registry. If I want to look in here, you can see I've used 0.01 gigabytes, which is about 10 meg. If I look in repositories, you'll see that my image has pushed up successfully. DevOps on Azure, V1, and you can see in here I've got 3 layers to my image because there really was nothing more to it. In the Docker image, each individual line that you write and execute is a layer in the image. So the less layers, the better. So how do we get that into app services? We are going to get into app services by creating an app service in the portal. Now, this is kind of where later on the line, the series where we'll automate all of this, but I want to show you this manually first. We go to create. I want to create a new app service. I'm going to choose the resource group, Liam DevOps series. I am going to call it, let's just say Liam's World Website. As you can see, I've done it before. And this is the reason I have chosen to do in Go. I could have done this in Node. Really simply, I could have just knocked up a Node Express server, just like I've done in Go. But the runtime stack isn't available unless it's updated in the past half an hour. Go is not on there. And Go is like a really fast growing language. Lots of people are adopting it. Lots of cloud providers are getting on that now. But we don't have a Go build pack. So what's your other option? Your other option is a Docker container. So I'm going to select Docker container. I'm going to put it in the UK South region, just where everything else is for me. I am then going to create a new app service plan because I haven't got one running already. So to have an app service, you need an app service plan. Kind of goes hand in hand. So it'll create one for me, but I don't need this SKU and size of premium. So remember I put basic earlier for my container registry. I don't need 3.5 gigabytes of memory to run this small app. I am going to use a dev and test one. I'm going to use a gigabyte and it's free, 60 minutes for free a day. It's cool. So you can actually give it a go yourself. I'm then going to move forward because with this plan, I don't get zone redundancy, which means I don't have a multi-AZ redundancy. So if my one goes down, it goes down, nothing I can do about it. But I don't mind about that because it's not detrimental to me. Next, I'm going to select Docker or where I'm pulling my Docker image from. Now I pushed it to my container registry. If I select my options, I have Compose. So if you have multiple containers, those who are familiar with Docker, Docker Compose will help bring it up and help network and sort of sort all your containers out in once. But I just have one container and I don't want the quick start. I want my container registry. And it has automatically populated it for me. So DevOps on Azure, episode number 1, which is today's episode, and version 1. Awesome. So next we want to go to monitoring. Again, if you want, you can turn this on. I don't need it on. I don't need to look at it because container logs is enough for me to gauge what's going wrong. If anything does go wrong. Tags is a really cool one because this is how you can tag your resources in your resource group. This helps you identify different resources that you've got. Again, I don't mind. I've not a lot in there, so I'm going to move past that one. And if I just have one last review of what I've got, so I've got the free SKU, which is just a free plan. I have got a resource group. It's the same resource group, so they can talk to each other. Called it Liam's World Website. It's a container pulling from this image, and that's the server that it's pulling. Wicked. Now I can create it. So if I click create in the bottom left, this doesn't take too long because if you remember, the Docker image that we created was tiny, and hopefully, fingers crossed, it spins up pretty quickly. It'll be the demo daemon if it doesn't, but that'll be quite fun to debug. So whilst that is going, this shouldn't take much more than a second. We have created an application, Dockerized it, put it into a container registry, so it's like my private store of images, and now I am pulling from it with app services. And it's going to grab it. So if I go to the resource, this will take a moment to load because it's like a cold start, just spinning up. But if I click on this link over here, if it shows up when it shows up on the right-hand side, There we go. So the URL is https Liam's World website or Liam's-world-website and so forth. Just take a moment to load up. But if you want to check out your deployment, you can go into the deployment center, which is on the left-hand side. And we can look for logs. And this is just connecting to the container logs, what's going on behind the scenes. But as you can see, the eagle eye may have noticed, we have got it running in Azure. We have got an application from my system into the cloud using container registry into App Services in Azure. So that is how easy it is to get it up. And that was super quick. I did that in probably less than 2 minutes, the whole from pushing or creating the application to it being live, really, really quick. So that is the hands-on element of episode 1. The next episode is going to be focusing more on automation. So if I jump back into my slides, recapping on what we've done, we have taken this application locally, plugged it into the cloud, and it all works. Next episode, which is going to be next Tuesday, is the 15th of February, and we're going to be introducing CI/CD. How can I create an automated pipeline? How can I eliminate some of those painful manual steps that I had to do? i.e. building the image after a change, pushing it to the cloud, redeploying it. We're going to automate some of that with some webhooks and GitHub Actions. So stay tuned for that one. Thank you ever so much for joining today. And I really hope you learned something and learned how to deploy into app services and how quick it can be. If you want to join our meetup group, please do. It's meetup.com/Microsoft-Reactor-London. My LinkedIn is there on the screen, and so is my GitHub and Twitter. They are the same handle. So please give us a follow, drop us a message if you have any questions, or if you can't make any of the further episodes. These will all be recorded. So yes, please do check them out. And with that, I will hand over to Rav. Thank you very much.
Thanks, Liam. We do have some questions for you in the chats. So you may want to, I'm just going to show you on the screen. So we have a question from the audience which says, what is the difference between continuous deployment and continuous delivery?
Okay, that is a good question. Oh, we have some echo. There we go. Okay, so difference between continuous deployment and continuous delivery. I apologize, camera's up here, but reading my screen down the bottom. Continuous delivery is partially manual. So there's a manual element to the steps in it, whereas continuous deployment is more edging towards automation and the automated steps and the tooling and utilizing some of the build tools and the release tools that are available to you. So that's the difference between the two.
That's great. I'm just going to pull up our screen where it shows you all the links. So on the screen, I have put some links on. We have our meetup group, so please do check out our meetup group, which is Microsoft Reactor London, for all the upcoming episodes. The next episode is going to be on the 15th of February, and at the same time, 4:30 to 5:30 p.m. GMT. So please do join us for the next episode, and you can follow our Twitter, which is Microsoft Reactor, and this episode will be available to view on YouTube in the next 24 hours. But thank you very much, Liam. Great session today, and we shall see you in the next one.
Thank you very much. It's been great being here. Thank you, everybody, for joining.
Thanks, everyone. Bye.